Today we are going to see the session about understanding of mainframe modernization. So right from basics, what is modernization? What are the different industries are using mainframes? How this modernization is important? What are the various perspective for the different roles in the industry? And how this becomes a significant in today's digitalization world. We're going to cover up everything with very clear understanding. By the way, myself, Vijayalakshmi, mainframe modernization expert, having 2 decades of industry experience. Throughout my journey, I've designed and delivered impactful modernization solution for diverse enterprise clients and helping clients to reimagine mainframe capabilities into modern tools, technologies, and DevOps implementation. With that said, let's get into the session. As I briefly told, so this is what the agenda we're going to cover, right from introduction to why it is, how to start, where to start, and what are the different perspectives and tools. We're going to cover it up till AI enablement. So to begin with, I wanted to start right from the basics of how the mainframe was labeled or tagged. Sometimes I mostly hear about this. The mainframes are compared with dinosaur, right? So why actually they're comparing dinosaur in the sense both are it's actually a legacy. It's very huge, costly, difficult to manage and maintain. Of course, yes. But if you look at mainframe, you also heard about another word called mainframes are going is dead. I'm even sometimes I hear from people, are you in mainframe still? Is it not dead? Or do you have so many other latest technologies? So in the sense, it is actually it's not it's keep on evolving or it is keep on transforming with respect to the technological changes. So that's exactly what we are going to look into that. So before get into details, let's see who are all the users of mainframe, right? So if you look at the overall industry, the retailers are almost 70% of retailers are using mainframe, and 8 out of 10 telecommunications are using mainframes, and out of 10, 9 banks are using mainframes, and of course, 8 out of 10 insurance companies are using, and two-thirds of Fortune 500 companies are users of mainframe, which means overall 60 to 70% of global transaction happens with mainframe. So, which means mainframe, you cannot get rid of it. You will be using the mainframe. When you say modernization, you are not exactly replacing. You may be transforming or modernizing this with the different tools and technologies. That's what we're going to see. What's happening in the modernization, how it can be done. And if you look at this mainframe servers, it since right from the beginning, the first mainframe system was System 360. It was from 1960s, and from today, these are all the various evaluation of system. Hopefully, I will just leave it to you if you can have a look into it. From 2000 onwards, the systems, whatever design is called as Z series kind of stuff. This is how it is named. The mainframers might aware of this. And the recent mainframe, which was released by IBM, is actually Z16, released in 2023, is actually AI-enabled processor. The processor itself is AI infused Telnum processor, which gives you the capabilities of AI into your mainframe applications, or maybe you can the capabilities infused in the processor itself. And this year, 2025, IBM has announced G17, which is again AI infused Telnum 2 processor with, of course, quantum sim technology also for the real time decision making. So, which means the hardware is keep on evolved or transformed with the latest the technological transformation. So we are up to date on the technological transformation, so we can make use of this for the latest evolving technological aspects. So now, why exactly this modernization is required? So basically, the legacy systems or legacy applications, whatever we have seen, right? Telecom, retailers, a banker, insurance, all these applications are written almost 2 decades or 3 decades before, right? So those applications have written with COBOL or PL/1 assembler, those languages. Those applications are not have much documentation. The the application which is written or which can be accessed through mainframe is ISPF panel interface, which does not have modern interface, or you cannot able to go through the program flow completely. So it's kind of a legacy green screen. You need to just scroll between the screens F8, F7 to understand your program. So it does not have a modern interface to understand the program. It does not have much documentation, and even talents. We have a huge talent gap in this, and these things will not adopt or integrate with the open tooling. That's how it was earlier, but these can be overridden with the latest tools and technologies. So to address these challenges, this need to be modernized. This need to be transformed. That's what we're going to see, how it can be done. So when you say modernization, so what are the different approaches are available in the market? And when you say modernization itself, there are, before looking into the approach, there are various questions will come into the picture. This is the biggest question mark. What exactly is the modernization? What do you mean by modernization? Some people will think that if the application is running in a cloud is a modernization, or what it is, right? So there are different aspects of it. So when you say modernization, what exactly is the modernization? And will I where exactly I have to start, right? What are the basic skill sets are required? What are the roles are required to get into the projects? And what would be the mainframe modernization from a role perspective? CXOs will think mainframe modernization in a different perspective. Developer may look into a different perspective. For system programmers, it may be different ways, right? So for each roles, for system programmers, developers, or CXOs or architect, the modernization means or how they can take it into their roles might differ. Okay, and what would be the benefit you can able to achieve with the help of modernization? How long it will take? From where I will start? How I will start? So all these questions will come in picture, and all these cannot be answered with a single statement, and it need to be thoroughly analyzed with the customer landscape, application landscape, infrastructure, and it has to be taken with a case to case basis. But we can strongly say how to start, where to start. That's what we're going to see it here. And so to do these things, we would say the applications which is written in the legacy languages have to be modernized to adopt with the latest tools and technologies, which is application modernization, which in turn demands your infrastructure modernization, meaning the system where it is running have to be modernized, and which in turn facilitate your process modernization, the way in which it has to be done, executed, right? The process change is going to happen when you modernize your infrastructure as well as application. So this is what we are going to discuss little in detail for the next 45 minutes. So as whatever I've said now, the modernization means you will have three different types: application modernization, infrastructure modernization, and process modernization, right? So as I told, the different roles for the developers, you can get into deep dive into application modernization area. For the system programmers, infrastructure people, you can deep dive into infrastructure modernization area. And of course, the process modernization way, it is giving you various other roles to get into this modernization journey with like a ZDevOps engineer, release engineers, and those things where the process has to be implemented with CI/CD implementations and pipelines, orchestration, etc. So these are the different types. So now to get into these modernizations, what are the latest hardware and softwares are available in the market? So as already we discussed, this is the latest Z17, which is with an operating system of ZOS 3.x, right, 3.1. So which supports with the chip processor itself is Telnum 2, A-enabled chip with quantum safe cyber security, and which supports your modern development. And yeah, So a little bit of what are the recent processor and processor capabilities. So since my experience, right? I've seen the processor with 20 core, 40 core, and now today, if you see Z16 or 17, it is 200 core processor with a memory of almost more than terabyte, 40 terabytes of memory, and AI enabled or infused processors with, of course, quantum safe crypto and generative AI capabilities as well. So as this is the latest OS, and with this integrated with the AI framework that enables to implement or enable your machine learning processor, generative AI capabilities, and you have an foundation model is well defined. You can fine tune it for your own customized application requirements very easily. Okay, and it also supports your DevOps containerization or pipeline orchestration, etc. And as you go along with this modernization, your operations also can be uh, improved, or it can be modernized with AI ops capabilities. Now, what exactly matters, right? So when you have an AI enabled uh, platform or operating system, or maybe hardware, right? Like for Z16 and 17, it also supports your cybersecurity or quantum safe cryptography. So actually, quantum safe is another important concept which is infused with this, where you can get rid of whatever the threats we have in crypto encryption and decryption methodology, right? And of course, that we will be covering in a separate session, which is an altogether is a big topic, and it supports your DevOps as well. So actually, if you look at the mainframe without when you have an advancement of technology, there was a misconception statements like mainframes are outdated, mainframes are too expensive, it is not compatible with the modern technologies and things like that. So it was totally misconception. It is mainframes are keep on transformed or evolved with the latest tools and technologies, and you have up to date all AI enabled or DevOps enabled and whatnot, cloud native application integrated capabilities with highly secure, scalable, cloud ready, AI enabled platform. Okay, so those things are misconceptions. Now, with respect to the application modernization, let us see little have deep dive into that, right? So when you say application modernization, there are various approaches are available in the industry. You might have heard about these 6 or 7 R's people used to say: rehosting, replatforming, refactoring, retiming, right? Whatnot. So these are the list. So all these are approaches. How you are going to approach your modernization methodologies. That is called as an approach. And to do this, you have and different technologies you can use or adopt. Microservices. It may be a microservices based implementation, or it may be a API integration based approach, or it may be a cloud native platform, or you can also have containerization or CI/CD implementation. So these are all the things of tools and technologies and approaches of your rehosting or refactoring. Let's see a quick glance about that. So rehosting in the sense, it just you're going to lift and shift methodology. Whatever is running on your mainframe on-prem, you're going to shift into your uh, cloud native architecture, right? Platform. So without any much of change. So which means it may take less time, less cost, and it may be very faster, but you cannot ensure because you're not doing any code change on your legacy application. So which means there is a question mark. The application, whatever is written 2 decades, you're moving as such cloud. You may get little benefit when it is running on the cloud, but you cannot get a fullest or complete advantages of your modernization, right? So obviously, because the anyway the code is its legacy, you may not have a prerequisite set for when you wanted to make use that as an AI enabled application. You may go wrong because we don't know the applications are written long back that may not support today's AI integrations, right? So I would say that there would be a limited monetization capabilities. So, but it can run on cloud. In a way, you can try to achieve little benefit on pay as you use, right? And those concepts, little bit of cost saving, but you will not get the fullest advantage of monetization. So that's actually rehosting. Replatforming, it's actually you're moving it to your cloud related infrastructure or platform where you will have little bit of a code change. It may give you better performance, but it may be cost effective also. But again, you are uh, keeping ahead with your legacy infrastructure. That again will have a little bit of uh, setback on your monetization, fullest capability of monetization. Refactoring is, of course, is the good approach because you are completely rewriting your application into a modern tools or modern technologies, I would say. So it is completely you are rewriting. So you will get the complete advantages of your modernization. So it will take time, it may consume time, but it is completely future proofing and you will have improved agility, DevOps, AI enabled, everything will be in place. And of course, it will be time consuming. And it requires good skilled resources to perform this. Okay, but it is foolproof, future proofing, and long term monetization. And replacing, when you say it can be replaced with your SaaS based application or cloud native application. So it may give you an easy way of monetization, but it may need to be a little bit of limitations when you try to make use of the fullest monetization capabilities. And retiring means little when we go for analyzing your modelization, some of applications may not be touched for the last 10 years or 15 years. We come to know it may be absolute applications or modules that can be decommissioned, right? It not at all. The applications were not called by any of applications. We can able to get rid of, we can decommission it. So that's called retiring. And retaining is just keep assets and maybe you will revisit when you go for a modernization. That's called retaining. And so what are these are the various approach. Predominantly your replatforming or refactoring would be the good approach predominantly people are using. Or there may be some places you will have some kind of an API integrations or microservices related aspects will use. Everything will be case to case basis. Now, after when you look into any kind of an application as an developer perspective, right? So, what are the various phases you will come across as a developer? You will do the code change. You will retrieve the source code from your any of the version control tool, and you will do code change. You will commit back, and you will compile your code. Maybe you will build the code. You will test it and you will package it and you will deploy, right? So these are the various phases you will come across. So in these phases, how we'll see the glance how it will happen in a legacy means how it would have been in the modern cases. So let us do whiteboarding. Anyway, it's an online session. I'm not going to use any boarding. Let's discuss now. So when you say when you are doing code changes in a legacy means you will have an ISPF panel, right? So from that panel you will get into you will do the code and 3.2 or 3.4 you will retrieve the code into your PDS and you will go through the code change. It's a green screen legacy and you will have a manual navigations and do the code change. In terms of a modern, you have a modern IDE. IDE stands for Integrated Development Environment. So there are environment like IBM Developer for Z, IBM Developer for Z on VS Code, Zuvi Explorer or VS Codium. Those tools are the modern interfaces which will have an Eclipse based or modern interface. You can see a little bit of a graphical uh, pictorial representation for your program called graphs and subprogram calls, how the program is going through. You can easily look into that representation and you can easily understand it and you can do the code change. There might be some code snippets also will be given to you, and any errors on the go when you edit, it may pop up with your errors and you can able to correct it, right? In legacy way, you will not have that benefit, advantage. You will get to know only when you compile and you will go and look into the compiler listing. So in a way, the modern things are like this. And when you say source control, version controlling, predominantly your Endeavor or Changeman or SCLM tools are being used as version control tool. It's again, you will have a menu-driven option. You may go through the version controls. Whereas in the modern world, in any kind of a Git-based SCM, GitHub, GitLab, or Bitbucket, Azure DevOps. So those tools can be used as an uh, version control tools, which will very much integrated with whatever the code editors we have discussed now, IDZ or Zuvi, Explorer, and those things. They can able to integrate it easily. And when you wanted to build your application or compile your application, either you will use your compile or linked JCLs, or maybe Endeavor processor will get invoked or changeman processor to do that. In that place, it can be done with a Groovy scripting or YAML script, and which will help you to compile being in the modern interface. And the packaging, of course, will use once again the Endeavor or changeman, whereas in the modern, you will have a YAML scripts which does your packaging, and your binaries can be kept in the separate repository called Artifactory. And deployment, it's again your Endeavor or Changeman, from where your lower environment to the next higher level environment we used to deploy with the help of the tool to move it to the next level, so that load library, the executables will get deployed into your load library. Whereas here, you can able to have an interface which is a web-based interface where you can able to see, take it to your automated deployment process, and you can easily go through the versions which are deployed with a good web interfaces, right? Urban Code Deploy or IBM DevOps Deploy are the tools for deployments. So from an application modernization perspective, so these are the various aspects how you have used in legacy, how you can able to see in the modern world. This is what I wanted to show you, the comparison. I hope so you have the much better clarity now, how these legacy way of working as can be equated to your modern way of uh, modernization after post modernization, how you will able to work with these tools in the modern front, right? So which means you are taking an advantage, and so these things will help you to take it for the next step of your what do you call, infrastructure and process modernization. Yeah, that's what you wanted to say next. So as to achieve this have to be dealt with some kind of prerequisite, right? So to do that, there are some additional installs need to be required on the Z side as well as on the Windows or Linux system. Let's say, for example, I wanted to use my Git. I wanted to have IDZ. So IDZ have to be installed in my mainframe host system. At the same time, the client will be running on my Windows system. So the Windows system where you'll have IDZ client, where your desktop where you can able to start, and IDZ host is installed in my Z system. There will be a connection. The agent will connect and the connectivity will be established. Of course, you'll be seeing next in the demo where I'll be connecting it with IDZ, and Git will do the coaching. You will be looking into the demo as well. So additional installs are required. And at the same time, when you say DBB, dependency based build, that runs on your mainframe, Unix system services in, and that will be small installation will be done. And your DBB server, which runs on your Windows. So it's a web-based interface where you can able to see it. So there is a same way goes for Jenkins. Jenkins, if you wanted to use for CI/CD, you will have agent running on Z, and your server, Jenkins server, will be running on your Windows or Linux. So these aspects come in the form of your infrastructure modernization. So when these things are in place, eventually we will get into an orchestration with the help of, that's what we call as ZDevOps or process modernization, where it helps you to orchestrate your complete pipeline CI/CD automation with the help of either Jenkins or GitHub Actions or GitLab CI or either Azure DevOps, depending on the customer choice. We can able to enable the CI/CD orchestration. So when you orchestrate, when you automate, you all these phases, your analyze, code change, version control, build, test, deploy, can be with the modern tools, which is described here in this. Either you can use for analyze, ADDI, WASI analyzer, or micro focus analyzer tool, or your ADDI, I mean ADZ or VS Code, Zubi Explorer can be your code editor. Your version control with Git based. Your build is actually dependency based build from IBM, or you have an Endeavor bridge, or you have a custom script which can test your build. And test can be with a various testing tool with the IBM ZBTP, or maybe there is an HCL test, or there are other testing tools which can be incorporated, and deployment with UCD, DevOps deploy, and maybe custom scripting also we can write for deployment. So this is a complete full end-to-end ZDevOps implementation we can able to achieve when it is modernized. Okay, so as you have seen the transformation, right? So it is going to take a lot of time, right? That's where we are saying this as a journey. Okay, and just to give you a quick glance on how your ISPF in the modern world, your programs can look like this. You have an interfaces which you can easily take you through, and you can, if you wanted to debug, you have a quick debug window you're able to watch. So it's much easy for a developer. It same goes with your VS Code and modern will. So whatever we have executed with your JCLs, right, can be in the form of a Java-based script. So this helps you to, this is just an, we are invoking your compiler here, IGYCRTCL, which is called from this library. And so there are some data sets which is required. We are preparing here. It's like CCT1, CCT2, right? Those data set. And you're executing here and you're checking your compilation. So this is a Java-based scripting which does your compilation in the modernized interface. So this is exactly what we call as a dependency-based build, which is a modern build tool that is having a capabilities to build your ZOS application, which is written on either COBOL, PL/1, or assembler Rex. It helps you to uh, do the compilation. So it is just a standalone product that is preliminarily available to compile, link it to your application. So yeah, you will be looking into the demo in this uh, in shortly in your coming videos. Will showcase how the code change and modern build happens. So as you have seen, whatever we have seen overall, 60 to 70% of a global transaction happens in the mainframe. It you could see the predominantly 70% of the global transaction happens in Z system or Z Linux one. In the last 3 decades, you'll have growth rate is 3x. So which means as huge transactions happens on mainframe servers or and operating systems, or there are tools or even supporting your modern latest technologies. So we say that this is obviously it's an imperative. The application have to be modernized to take the advantage of the modern uh, tools and technologies. So in a way, AI on ZOS, it's a strategic imperative. So we need to accelerate it can be accelerated mainframe modernization with the help of AI based automations. So why mainframe modernization with an AI? As you have a huge data. Globally, 70% of the transaction happens in the mainframe. Just imagine there is a huge data which is still hidden within AI or data. So you can able to data centric platform, you can able to avoid your latency, and it's a huge security risk can be addressed with the help of AI capabilities. Proactively, you can do some real time decision making. You can able to detect proactively some kind of a threats, and you can able to secure your applications. So in a way, you can make use of AI for your monetization applications. And as we have already seen, the hardwares and softwares are AI enabled. It's an AI ready systems and AI ready softwares. And you can also see your uh, AI ops related operational activities also shortly once it is modernized. So there are some AI driven monetization tools also available, which will ease your monetization journey. Maybe the time factor it may able to reduce. So you have a Watson X code assistant for Z that will support you to automatically convert your COBOL code into Java. So your COBOL code returns on 2 decades or 3 decades before does not have much documentation. If you wanted to understand the program fully, so you need to put the resource and they have to manually go through the analysis, which is cumbersome process. So to avoid that, this tool, what it does, it automatically picks up your code and does a complete analysis and prepare the documentation for it, and then it converts the Cobalt code into equivalent Java classes, and it will also prepare your unit test cases and compare the results between two and ensure that it will validate and verify that the code is converted into Java and unit tested or tested and verified. Okay, so you can able to refactor with the help of this tool easily with less time. And what's the next assistant for Z, which will help you to prepare some kind of an agents or bots for any kind of an operational activities for the maybe banking or insurance applications. You can able to easily make use of this plan bots with the help of what's an assistant for Z. And of course, you have an A ops capabilities which will proactively detect and fixes the issue, incidents, and the problem management areas. So, as whatever we said, the real world impact, it's because of the AI infused with application and infrastructure. It can be obviously the faster, and your incidents can be addressed very quickly at the fast responses, and you can proactively detect some kind of a fraudulence, and you can able to stay along with your compliance. And so as a business benefit, so it can be right short term, you can able to do once it is modernized, you will get an agility speed faster to the market, and it will improve the developer productivity with the modern tools, and talent onboarding is much easier, and it is a cost effective solutions, and you are also working with the cutting edge technology, adopting with an hybrid with along with AI and hybrid cloud or hybrid cloud approach. And path forward, as you have OS and hardwares are available with the AI enabled framework, it can be uh, used with the help of whatever the data you have, and your policies are available. Workload can also be automated with the help of ZOSMF. So these are all kind of an advantage, and there is an successful use cases which is demonstrated for fraudulent detection for a credit card kind of an applications, and chatbot support for all of your banking and insurance applications have been demonstrated. So we have one complete reference architecture enabled and tested. So we can easily able to make it for the next steps with the help of these tools. So as of course, these are the advantage. We can improve the developer effectivity and agility. DevOps adoption, and low operational cost, licensing cost can be enabled. And yeah, you can able to get rid of your shortage of a skill gap, and you can able to prepare your talent with the latest tools and technologies. So these are all the tools which you can use for your modernization. So IBM Developer for Z for a development, IBM Application Delivery and Discovery and Delivery Intelligence, ADDI for analysis, application Z development and test environment for your development and test environment, ZOS Connect for API enablement or API integrations, and Java and Z for a Java workload. So there are some kind of an AI ops related capabilities with Z operational log and data analytics product, which will help you for real time monitoring and proactive problem solving uh, related aspects. So these are all the modern tools which you can use for your applications, modernization, of course, monitoring also. So there are some successful case studies with the various customers to give your benefit of the developer efficiency or the cost savings. So this is about the cost savings with the adopting into DevOps adoption. And here is the improved efficiency of developers with the help of developer for Z and modern build. So to as a overall the outcome, the modernization gives a better uh, outcome with the help of the faster to the market and developer efficiency, lowering the licensing cost, and AI enablement and API integrations. And there has been a complete containerization concept with zero downtime. So these are all the reference materials which you can refer, and you can able to make use of it. We will also provide you some references in our chat. So with this, I'm concluding this session. I hope so you would have got a bit of clear idea on modernization and how it can be achieved. So these modernizations are very big and something you have to start from the small thing, and you we will take kind of a pilot. We'll try to understand the client application, uh, how it is landscape, what is the volume, how it is available, feasibility factor, and then we will take it up to the next session. So we'll start from small pilot, do the pilot study, and then scale up for the entire application modernization kind of stuff. Thank you so much. You can able to see the reference videos which is given in the description. Thank you. Keep watching us for the forthcoming videos on modernization related concepts and practical demos. Thank you.